Hello, this is Mr. Bausma from Colonial Christian School in Homestead, Florida. Last time we were talking about making a blimp out of a garbage bag, some straws, and birthday candles. And you recall from last time that we calculated how big around the blimp would be by stretching it out and then calculating the circumference as twice the radius, that's 1/2 of the distance across, times a special number named pi. Then we stacked up a series of these disks in order to make a cylinder, and we calculated the volume of the garbage bag. And as you recall, that volume ended up being 3,100 cubic inches. You'll recall also that we talked about temperatures as well. If we assume that we start off with a toasty temperature of 80 degrees, because this is Homestead in South Florida, where the sun shines and the birds all flee when they're cold from up north. We start off with 80 degrees Fahrenheit, and we raise the temperature up to toasty 140 degrees using the birthday candles. We're going to have to convert these numbers from Fahrenheit to degrees Kelvin, because the way that chemical formulas work is they start from the coldest possible temperature, absolute zero, which is 0 degrees Kelvin. Let me show you the equation for doing that. If you take the temperature in degrees Fahrenheit, this is the degree in Fahrenheit, and you subtract 32 degrees for the temperature of the freezing point of water, and we multiply that by 5/9, you get degrees Celsius, and then you add 273 degrees, you get the temperature it would be in degrees Kelvin. So let's do those conversions. If we convert 80 degrees, you end up with 300 degrees Kelvin. And if you convert 140 degrees, you end up with 333 degrees Kelvin. Those numbers now are going to plug into a chemistry equation. The equation looks like this. If you multiply the original pressure, that would be the pressure of the atmosphere here at sea level, and you multiply it times the volume, that's the 3,100 cubic inches, and you divide by the temperature, that will be equal to the pressure. Wait a second, the bottom of the blimp will leak out, so the pressure will be the same. These two will be the same, times the volume divided by the temperature. Now, if the volume changes, that air is going to leak out of the bottom of the blimp. That means there's going to be less air inside of the blimp than there is outside of the blimp. And by figuring out the difference in the amount of air that's not in the blimp, we can find out how much less the blimp is going to weigh than the air around it. So let's do the math. All right, we have 1 atmosphere of pressure. So that's 1 times, the volume, what was that again? 3,100 cubic inches. Divided by the temperature in degrees Kelvin, that was 300 degrees Kelvin, which was the temperature 80 degrees Fahrenheit. And that's always going to be equal to, according to the ideal gas law, the new pressure, which is atmospheric pressure, 1 atmosphere. times the new volume. Some of it's going to escape, so some of that volume is going to be gone, times the new volume divided by the new temperature, which is 333 degrees Kelvin. Now, if you remember back from pre-algebra, cross multiplication, we can get rid of these horrible looking fractions by cross multiply. If you cross multiply 333 times 3100, we can ignore the 1. Then you end up with 1032300. Then we'll multiply across here and we end up with that's equal to 300 times the volume. Then if we divide, we end up with 3,445 is equal to the new volume. Well, remember the original volume was 3,100. So if we subtract, you end up with 345 cubic inches of air that was forced out of the blimp. Now I looked up how much air weighs. Air weighs 0.00075 ounces for every cubic inch. If you multiply how much that weighs, and we have 345 inches of air that's missing, then you can find out how much lift the blimp would have at a temperature of 140 degrees, which we could measure. And if you do that multiplication, you end up with 0.26 ounces of lift. Thank you very much, and have a good day.